this video, we're going to talk about exponential functions. An exponential function is a function that's in the form of y equals a to the x, where a is called the base, x is called the exponent. If the base is between 0 and 1, that is, it's a fraction, it's going to be a decreasing function, like so. We'll talk more about this with the graphs of exponential functions next time. And if the base is greater than 1, it's going to be an increasing function, like so. That's assuming that x is that you have just x in the exponent like that. We can get into all kinds of transformations of these graphs, and that'll be the next video. But for right now, we're going to focus on determining if something is exponential, and we should be able to figure that out by seeing if it has a common ratio in its terms. So right now, for instance, if I take 9 divided by 7, is that equal to 11 divided by 9? Let's multiply here. Is 81 equal to 77? It is not, so this is not exponential. Let's now take 1 divided by 8 over 7. Is that equal to 7 over 8 divided by 1? Let's multiply here. 1 is equal to 1. And my base here is going to be the multiplier of 7 over 8. That's what I'm multiplying by each time to get to the next term. So I can figure that out by taking the ratio of any two terms here. I see that it comes out to be 7 over 8. Let's go ahead and work through some examples of exponential problems here. So the function d of h is equal to 7e to the negative 0.4h, where h is the time in hours and d is the dosage, or you could say concentration in milligrams. Here that will be present after a certain number of hours. So we want to find the amount of drug in the person's body after 5 hours. And we're going to have to pull up our calculator to do this. Seven second e to the power of negative 0.4 times 5, and seven, 3, 4, 6, 9, 8, 2, 7, I'll say is approximately equal to, because that last digit is rounded. And it says that it wants the answer to 2 decimal places. And these are in milligrams. The formula P equals 14.7 e to the negative 0.21x gives the atmospheric pressure in pounds per square inch. That would be PSI as a way to abbreviate that, at an altitude x, and miles above sea level. So find the average atmospheric pressure for an altitude of 2.3 miles above sea level. 14.7 e to the negative 0.21 times 2.3. Let me write that step down. 14.7 e to the negative 0.21 times 2.3. We get that 868,404 psi, and we're told to round to the nearest tenth. (9.1 psi). Let's try number 5. The function f of x equals 700 times 0.5. That's the same thing as 1/2 to the 2x over 60. This is probably a half-life problem. Yep, it is. Models the amount of pounds of a particle of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. So the way I would read this is that it takes 60 years to have radioactive decay so that only half of the original material is left. So in 60 years, we'd have 350 pounds of material. We started off with 700 pounds. So we want to know how much we would have in 170 years. (700) times 0.5 raised to the 170 divided by 60. And we get the f of 170 is equal to 98.215,42923, and this is pounds. And we want to round to the nearest whole number. So f of 170 is about 98 pounds. Right. Let's finish up some properties of exponential functions with the next 2 questions. If 2 to the x is equal to 3, 2 to the negative 3x is equal to what? Well, 2 to the negative 3x is 2 to the x raised to the negative 3rd power, because when I raise a power to a power, I multiply the exponents. So that's going to be equal to 3 to the negative 3rd power. The 1 over 3 to the 3rd is 1 over 27. And then if 6 to the negative x is equal to 1 over 5, 36 to the x equals what? So this is if 6 to the negative x equals 1/5, then 6 to the x equals 5. And this is 6 squared to the x, which, because this is multiplication, I can change the order of multiplication and it doesn't matter. 5 squared is 25. Yes, that's it. Next time we'll come back and talk about graphing exponential functions.